So we are going to continue talking about rational expressions, which we introduced yesterday. And we finished yesterday by looking at multiplying and dividing. And basically, when you multiplied and divided, what did you really end up doing to those expressions?
You multiplied and divided. Oh, no.
We needed to find if they had any common factors. That's going to be today. That's not going to be, that was not yesterday. That's going to be today. All right. Yesterday was multiplying and dividing, which is just basically an exercise on, do you know how to factor or not? Because if you know how to factor, then you can cross out, make one, any of those common factors to simplify. All right. And there was one other component. What was the other component that I taught you yesterday that sometimes you have to do? No, that was, you should have done that from last semester. Remember I asked, identify values that make the expression undefined. What did that mean to do? But most importantly, we can't have the denominator become 0. So we had to write what values can x not be. So it can be anything you want it to be except values, no, not 0, values that made the denominator become 0. Okay? All right, so today we're going to do addition and subtraction. And you guys in the rewind already did some addition and subtraction of fractions. So the only difference is that we're going to have what in our expressions? We're going to have variables. Okay? Now, we must have what in order to add or subtract fractions? Same denominator. Okay? So for this first section, you're going to notice we have the same denominator. So what are we going to do with the numerators? Just add or subtract, whatever it says to do. So I know that my denominator is going to be what?
X squared plus 1.
Very good. All right, so I'm just going to do 3x minus 4. And now this is up to you. I leave it up to the student. Some students just go ahead and use the calculator and do subtraction. All right, but I see a lot of mistakes are made. So I would recommend doing addition and doing what to each of these? Making them the opposite sign. So if this is a positive 6x, when I change this to addition, it's going to become negative 6x. Same thing for positive 1. That's going to become negative 1. All right? So just remember that you're subtracting both of these things. No, so once I distribute the negative and make it addition, the parentheses are gone. All right, so that's why I put parentheses here. So if you wanted to do it right away, 3x minus 6x, that's the same as doing 3x plus negative 6x. And what is 3x plus negative 6x? Negative 3x. All right, and again, negative 4 minus 1 is the same as negative 4 plus negative 1, which is not negative 3. Negative 5. My tone did not say anything about like being mean there. But now it is. That was Guillermo, by the way. All right, so the denominator is still x squared plus 1. Now, today you're going to see, after you get done with them, after you get done, you want to go ahead and check. Can I factor the top or the bottom?
No.
Yes.
Can we factor x squared plus 1?
No.
Remember, dots stands for what? The difference, and this is not the difference. That's the sum. That would be sots, and that's not a thing. So can we factor anything? No, so we're finished. So if we go back to the instructions, does it say anything about identifying the values that make it undefined? No, but does it say that I need to assume that they are defined? No, so technically I need to do what? Find the values that would make this equal to 0. All right, well, we're not going to do that. All right, but I just want to show you that we have done that in the past. So this is subtraction of these two expressions. Any questions?
No.
So when they have the same denominator, you can go ahead and do what to the numerators?
Subtract or add.
Subtract or add.